Good. Okay. Hi, everyone. Apologies for the delay, video conferencing and all that. My name is Andrew Seigner. I work at Buoyant. I'm sitting next to my good friend Akash from ForeSee. We're actually sitting right next to each other. So thanks for joining. Today, we're going to go through a couple of interesting demos, focusing first on Linkerd itself, and then how ForeSee built their infrastructure on top of Linkerd. So I'm going to focus mostly on kind of the general platform and how it works, and then we're going to see how it was implemented in like a real production scenario. If you have any questions, please add them to the polls. And if you see something weird or something's not clear, feel free to mention it in the chat. So I'm going to go through a demo right now and walk you through kind of setting up a few components in DCOS. So first off, let me give a quick description of exactly what we're doing. We're going to deploy, we've got a DCOS cluster of about 7 nodes. I can show you here. Right now, there's nothing running on it. It's a pretty fresh install. You can share screen. Oh, thank you. Sorry, I'm going to share my screen now so y'all can see what I'm doing. Thank you. Okay, great. All right, that looks awesome. Okay, so we're on DCOS. I've got a fresh cluster set up, 7 nodes. One of them set as public, just so I can access it from my laptop easily. So what we're going to do, we're going to deploy a Linkerd onto every node. That's going to enable routing between our applications. We're going to deploy a Namerd, which is also brought to you by Buoyant. It allows for dynamic control of routing between all of your applications. We're going to deploy Linkerd Viz, which is a nice metrics collection and visualization. It's like an observability stack. It's kind of custom tailored for Linkerd. But again, this is all open source. Everything we're showing you today is open source. Then we're going to deploy a sample application called Hello World. It's actually composed of 3 different components, a front end called Hello, and then 2 backends, a World v1 service, which is kind of the default backend, and then a test backend, World v2, which is actually configured to fail 30% of the time and to cause 100 millisecond latency. It's intended to demonstrate what happens when you deploy a new version of a service and it's not performing so well. We'll kind of walk through the steps of how do you turn up traffic to it and kind of turn back down for recovery. And then once it's all deployed, like I said, we're going to practice like shifting traffic between those 2. So just to start off, here's our blank slate. We've got our DCOS dashboard here. I'm going to start deploying components. So as I mentioned, everything in my part of the demo, it's going to be open source, so you can pull all of this off of our Linkerd examples repo, and that's exactly what I'm doing right now. I'm going to add a marathon config file for Namerd directly from our Linkerd examples repo. So I've created that deployment. We should see it deploying now. While that's deploying, I'm going to keep going with a few other things. Once that's up and running, we should be able to see an admin page. It takes a moment to come up. Okay, it's already up. Nothing too exciting yet because we don't have a lot running, but we're going to dig into this page in a moment. What these are routing rules for controlling how our services talk to each other. So once we get a few services deployed, we're going to come back here and play with this a little bit. So the next step is to deploy a Linkerd. There's one trick about deploying Linkerd is you need it on every single node. So what I'm going to do is I'm going to download our default example that we provide, and I'm going to be sure to set it to 7 nodes. That way it gets onto every machine. So here in our example, we've set to 4. I'll set it to 7, save it, and then we're going to deploy that thing as is. So if we go back to our DCOS dashboard, we should see Linkerd deploying all 7 nodes right now. It's a little bigger too. Okay, and then once that's up and running, we should be able to access an admin page for Linkerd, similar to how we just looked at Namerd. So you see our Linkerd admin dashboard is coming up, and this provides kind of basic like request level information for one particular instance of Linkerd. We're just looking at one right now, not all 7. Okay, next step, we're going to deploy Viz. So this is our observability stack. So what this will do, Viz is kind of a composition of Grafana and Prometheus. So it uses Prometheus to gather all of the data from Linkerd, and then it uses Grafana to show it on a nice dashboard. So we should see that coming up in a moment. Where's my Viz? Oh, right. So one more step, once we've downloaded our Viz config, just for demo's sake, Viz is configured to collect data every 30 seconds, which is, pretty common for production use cases. Maybe most folks go a minute. For this demo, I don't want to wait 30 seconds for stats to show up. So I'm going to set our scraper interval to 5 seconds. This is an environment variable you can set in Linkerd Viz, and it'll collect data at a very high rate. I would not recommend this for production uses, but for our case, it's just fine. So we're going to add our application here. We should see Viz start to pop up in the DCOS dashboard. And then we're going to open up the default Grafana dashboard once it's up and running. Initially, we're not going to see too much because we're not really issuing any requests. In fact, it hasn't even discovered the Linkerds yet. But in the back end, it is configured to find all of the Linkerds running in this cluster. Viz can work on DCOS or Kubernetes or other platforms and service discovery systems. And you just tell it what platform it's running on, and it knows how to go and find all of the instances. So now you see it's found all 7 instances. Again, we have no real data here, nothing of particular interest because we're not running a request yet. Something to add is, in addition to the default dashboard we provide, we've recently added a health dashboard. So while this page you're looking at is great for knowing how your services are responding, when you get into the range of tens of thousands of QPS and you need to start tuning Linkerd, this dashboard can be extremely helpful. This is stats that are specifically about Linkerd's health. So CPU usage, memory, garbage collection, all of that. So this can glean a lot of info if we find ourselves needing to tune Linkerd in specific ways. So we're not going to need that today. We're not going to be doing super high volume, at least on my side. But on here, this will be fine. So we'll go back to the health the Viz dashboard, leave this as is, and then let's start playing with a few requests. So now we've got our infrastructure deployed. We're going to deploy our Hello World application. So as I mentioned earlier, this is going to deploy kind of a suite of a few different components. There's our Hello app, our World v1, and our World v2. Note the World v2 doesn't have a health check on it because it fails 30% of the time. That was intentional. So it's not going to show up as healthy in DCOS. So now that it's deployed, we should be able to route to it. So this command is really where everything gets tied together. Let's just kind of go for it, and then we can explain what happened. Okay, so this was a successful request. Let me make that a little bit more visible to all of you folks. So what just happened here? We did a regular curl command at an address that's very specific to how things are named in DCOS, but what we used is Linkerd as a HTTP proxy environment variable. So the public node is just one node on my DCOS cluster. 4140 is where Linkerd runs. And from there, this is how all of your applications can talk to each other. So note the address hello.hw.buoyant. That matches the name in DCOS. So the app is called Hello in the group HW in the group Buoyant. And you'll note that when we issued that command, we got back a response that included data from both services. So this component came from the Hello service, and this component came from the World v1 service. So we kind of know that everything's talking to each other. And if we run this a bunch of times, you'll notice that the IPs are changing because we have 2 instances of all of these components running. Linkerd is going to intelligently load balance between all of them. depending on latency and success rate and all of that. So now that we've successfully shown that we can route between all of our services, let's play around with shifting traffic a little bit. So in the most kind of basic test case, we can use our Namerd dashboard to test out a routing rule. So as I mentioned, these rules here, they're called BTabs. They control how we route things through our cluster. So if I look for something called worldv1.hw.buoyant, very similar to the curl command that we ran earlier, you'll see these are kind of the steps that Namerd goes through to figure out where to route your request. It takes a name as input, it parses it into a way that Marathon understands, it gives it to Marathon, and then Marathon comes back with the addresses. And at that point, that's where Linkerd takes over and can decide which address to send it to. So for a little more interesting case, let's play around with dynamically modifying these rules. So no, we're not redeploying anything. We're just going to modify a few routing rules to see how that changes behavior. So we're going to go ahead and edit our routing rules here. I'm adding one new rule that says any request destined for world v1, forward it to world v2. So when I hit apply, you'll notice our old route is still down here in white. But what will actually happen is Namerd notices something's destined for world v1. It will reroute to world v2, and then we get new addresses that are for the world v2 service. Note, this is all, this change is only happening in this little playground that we've built in the Namerd. We have not affected any of our production services. So it's safe to kind of play in here and modify and experiment with your routing rules until you feel comfortable, and then you can start using it in a slightly more production way. So let's do that now. Let's try it from that same curl command. So if you recall, we go back here and we run this, and this is kind of our default route. We call hello calls world v1, and that's it. If we want, we can insert a routing rule directly into our curl command. So you note that same routing rule that I posted into Namerd's admin, we can pass it as a header to Linkerd, which then forwards to Namerd. So note that because I made that override that said send to world v2, we've now gotten our response from world v2 instead, which says earth. This is pretty important for folks that are running multiple services where an external service, an external request can hit multiple services internally. If you're a developer and you want to test a new version of a service that's somewhere in that stack, it's sometimes challenging to kind of insert a modified version of a service in the context of a whole bunch of services calling each other. This allows you to do it in a very dynamic way. So you can deploy your service, it doesn't affect production, and then you can just kind of poke it with these curl commands and test it in the full context of your production stack. Otherwise, you have to do things like stand up completely separate production stacks with all of your services. That can be pretty costly. So this provides kind of a nice dynamic way to test this behavior. Okay, so now that we've successfully proved that we can route to Earth, and just for fun, I'm going to run this a few more times to note that we should see some failure if I run it enough, because it should, oh, there we go. So we got a few 500s because our World v2 service is configured to be slow and to throw errors. So that'll be interesting in a minute. So now that we've successfully done that, let's put some real load on our system and watch as we kind of gradually roll traffic over. So I'm going to just open a separate tab here, and I'm going to run a kind of a load command. I'm going to put 100 QPS on the system. Now, this is using our tool called Slow Cooker. It's you can check it out, again, open source. It's kind of a nice way to put load on your system and get back some interesting metrics. So now that we've put load on it, we should be able to go back to our Viz dashboard and see, here we go. So now we've gotten some more stats. So because we started routing requests through hello, world v1 and world v2, Viz notices we now have 3 services going. If we kind of browse through our dashboard here, we get some top level metrics on success rate and global request volume. And then we can go down a little bit, and note that it creates separate sections for hello, for world, and for world v2. You can see the load I'm putting on it right now is all for world v1 because that's like our default route. And you can see that it's balanced 50 RPS per node. So we're sending 100 RPS to Linkerd, and Linkerd is balancing over those two. The reason you see 200 RPS globally is because every request we do generates 2 requests, because one goes to hello and then another one goes to world. So this kind of gives you a top-line view of every request that's transiting through your system. So now that we've got real load on the system, let's play with really changing our routing rules globally. So we're going to use yet another open source tool called NamerCuddle. So Namerd has an API that you can interact with, the same way that I was changing routing rules at the command line using host header or via the admin dashboard. You can also programmatically affect those routing rules. So what we're going to do is use NamerCuddle it just kind of wraps that API for you and allows you to dynamically view and update these routing rules. So we're going to save our current routing rules to a file. Then we're going to edit the routing rules in place. And I'm going to add that same line to the routing rules like in this file. And then I'm going to upload the file, and we're going to make like a permanent change to our routing rules. So note, this is that same rule. It says route v1 to v2. So we're going to save the file. We're going to do an update back to Namerd. So as soon as we do this, all traffic should shift 100% from world v1 to world v2. So what we would expect to see is our latency should go way up. Our error rates should go way up also. We should see traffic fall off to the world v1 service, and we should see traffic spike to the world v2. And here we go. So request volume's down, probably because we're hitting errors and we're slow. Notice world v1, all of its traffic is now at 0, and world v2 is ramping up to 100. Although again, it's erroring quite a bit and it's very slow. But this is kind of like a full like 100% turn on of a new service, which you should probably never do in production, but it makes for a fun demo. So now that we know we're kind of in not a very good state now, our error rates are way up. You can see our success rate here is at about 2/3, which is kind of how we've configured these services. So let's go back and do a slightly more interesting routing rule. So we just put 100% of our traffic on world v1. That's not great. A more interesting rule is to say let's gradually put traffic on. So instead of doing 100% to world v1, we can use our routing rules to say send 75% of our traffic to v1 and 25% to v2. So this is more of a gradual turn up. So you can kind of see where this is going, where you get to a point where you could integrate this into a CI system and gradually turn things up like at a fraction of a percent at a time. So we've now updated our rules again. So we should see things recover somewhat. It's not going to recover all the way because we're still putting 25% load on the world v2 service, but things will recover a little bit better. So again, you could imagine a universe where this integrates into kind of your automated deploy system where you can just kind of increase traffic very incrementally. And I definitely encourage you to check out all of our examples and our blog posts that demonstrate how to do this. So this is kind of the end of my piece. So now that we've explored I'm going to stop sharing my screen now. Sorry. Let's see. How do I? Oh, stop sharing. So now that we've kind of learned all of the foundational stuff that Buoyant's built, Akash is going to show us how to make this happen in like a real production setting and how they've used it. So one moment while we switch some Ethernet.
I was just quickly introducing myself, and I'm Senior Director at ForeSee and run our Big Data and AI platform team. And we built this on top of DCOS using Linkerd. So I just want to talk a little bit about why we chose Linkerd, just show it in action, as well as talk about what our observations were so far using Linkerd. So who's ForeSee? So at ForeSee, we are a customer experience analytics company in what's sometimes also called the voice of customer space. And we measure customer satisfaction for a lot of big brands that are out there and a lot of big online retailers, financial services, so on and so forth. We collect a lot of data about their end users along various touch points that they have both on mobile and web and kind of like different other data sources. And then we try to analyze the satisfaction and try to do predictive analytics, try to understand what are the drivers behind satisfaction, and kind of help our customers sort of get better with their users, essentially. And so the type of data that we collect is a big mix from a lot of different sources. There's structured data, there's unstructured textual data, there's things like surveys and feedback, and there's third-party data that comes in. And net, I think it's hundreds of millions of events today, and we're looking to scale this out to sort of billions of events per day. And to run all of this and to be able to do all the analytics and AI, we built out a big data and AI platform. And the platform was built to do this sort of big data analytics, to be able to do all the exciting new machine learning that's happening out there today. And it was also built not only for today, but also looking at where we want to be in the future, a couple of years down the road, what our requirements would be and how things would change. And so we wanted to build something that was going to last a little while. And nonetheless, that implies like everything that we took a dependency on was also, should last a while. So that's sort of what we wanted to design for. And if we looked at the kind of workloads that we were running, we had a lot of heterogeneity. So the apps that we're trying to run on our platform are very heterogeneous. There's a big real-time streaming pipeline that processes these, up to billions of events in real time per day. Then at the same time, there are analytics batch jobs that run. There are AI batch jobs that run periodically, which obviously a lot slower, but churn over a lot of data. There are big data queries that run at the same time. So there's a lot of heterogeneity in the platform, and the code itself is very heterogeneous. So there's Java code, there's Spark code, there's Python code. Some of this, all deployed as microservices and kind of running on top of the platform. And our load itself also changes. So especially because some of our customers are in the retail space, there's hourly changes in load. There's daily changes from like weekend to weekdays and seasonal variations whenever people have specials or Thanksgiving. And so the platform had to like adjust itself and dynamically scale up or scale down. And to be able to handle the load, and also to keep our costs low, because that's another very important factor for us at ForeSee. And so to achieve this, we built essentially everything cloud native. Everything was designed to be cloud native from ground up, and deployed as containerized microservices on DCOS. And that allows us to sort of co-locate and to be able to scale up, scale down. Things move around as things fail. We don't have to worry about what's running where. And then at the underlying glue for all of this is really sort of our networking mesh that has to tie all of these microservices together, make sure that everything is working at scale, make sure that it's really resilient towards any failures as services move around, make sure that all where shine for us. It's the thing that ties our entire platform together. It's the thing that makes sure that everything is always running, and we don't have to worry about the connectivity between services at all. So that was sort of the main reason why Linkerd is really a success for us at ForeSee. So really quickly, I was just going to show a quick architecture slide. I'm not going to spend too much time on this, but the only real key takeaway over here is that we've got lots of boxes using lots of technologies. They all talk to each other. There are lots of kind of lines interconnecting all of these things. And so the underlying networking platform is really critical, because that really ties these things together and makes sure everything is working all the time for us. And I think at one point we even tried to draw out all the different microservices that we had and what was talking to whom, and you know, it does get really, really complex over time. So that said, I'm going to do a very quick demo for you guys. So let's hope I can get in. All right. So this is Linkerd Viz. This is running on one of our environments up at ForeSee. And let me try to refresh this to make sure. Whoops. I think I've lost connectivity to our VPN somewhere. So let me try to get back into our VPN.
I tried turning off Wi-Fi.
Okay. All right, looks like I am in the VPN. Perfect. Looks like Linkerd Viz is loading up there. And as Sigi was showing us earlier, you know, this is kind of like a high-level network view of what's going on in our cluster. And right now, there's just very little load. I think some background load that's running, but nothing really running against it. We've got 10 instances over here. So I can try and inject a little load into the system. I'm just going to run a very light stress tool that we have, just run a very light load on it. And as that picks up, I think we should see the global requests go up, and about 10 requests a second is what I'm pushing in. So it's very small. And you can see that picking up over here. You can see there's no 400 or 500 errors, which is good. You know, everything looks good there from a networking perspective. We can also look at the total request volumes broken down by service that we have. And if I scroll down here, we can look at our individual services that are deployed, and we can look at what's happening from a network perspective for the services. So here's sort of the ingestion service that we were driving load into. You know, here are all the instances and kind of like the load over there. We can look at the latencies that the different instances are able to or sort of are experiencing. And so this kind of out of the box gives us a very good high-level network view of what's going on. We didn't have to do anything to implement this. You know, it just came out of the box and just works. So let me go back. What were our observations so far? You know, we found that using Vertex, which is an asynchronous microservice framework for Java and other polyglot systems, along with DCOS and Linkerd, worked very, very well from a resource savings perspective. You know, we saw about 20x resource savings over sort of Dockerized legacy Spring Boot applications that we had. And that was really, really a big thing for us, right? With Linkerd, we had very low latency, very high throughput on our cluster, so we can scale to billions and billions of events per day. And because of the high resource utilization and the high throughput, you know, it just meant a smaller cluster size, which really means, you know, a lot of cost savings. But also it means that we can process more data, we can collect data from different sources, and essentially, you know, we can make our offerings better. So it's a big win-win for us by sort of implementing in the way that we had, right? Linkerd plus DCOS, you know, just works out of the box. I think this is, I can't stress this more, is very, very important for us. You know, as developers, we never ever want to debug these really weird network issues where one instance of a microservice cannot talk to another, you know, 10 times out of, you know, 10 times in an hour, and then someone sees glitches in the UI somewhere. Such issues just never happen. You know, there's no hiccups. We scale up, we scale down all the time. We redeploy our services all the time. There are new versions coming out all the time, but things just keep working in the underlying to take Linkerd to production. And at the same time, Linkerd Viz gives a nice network visualization for what's going on right out of the box, again, without us having to integrate with it. And that was kind of nice. Really like that. And lastly, coming back to our point that we're a very heterogeneous system, because of the way Linkerd is implemented, being an HTTP proxy, it means that There are no client libraries. There's no client code. You don't have to worry about, if we start having Node.js code tomorrow, is that going to work well? If someone wants to write Go or services in Go or any other language, is that going to work? It just works. So, so we can pick the right language. We can pick the right platform. The connectivity between microservices always works, right? And if you think about microservices, then service discovery and optimized routing are a key aspect of microservices. And now that's almost transparent to us. We never think about it as developers in our new platform anymore. We just don't have to. It happens under the scenes, and because we don't have to write any code to make it work, we just don't worry about it anymore. And lastly, as I mentioned, polyglot and heterogeneous systems work out of the box as well. And so these are some of the reasons why we are very happy and felt like it was a nice win for us by taking dependency on Linkerd on our DCOS cluster. So, so I'll open it up for questions. And Siggy, that's
great.
Yeah.
Thanks a lot for going through that. So, yeah, if any folks have any questions, that was the end of our demo time, but we're definitely open to going deeper or clarifying anything we just showed. So we'll just give you all a minute to think about it.
Let's see. I think there's a question for you, Steph.
Oh, Nicholas asked using gRPC. Great question. So in the demos that we just did, at least in the one I did, it was just basic HTTP1, but Linkerd does support gRPC. I'd recommend checking out some of our recent blog posts and our example apps in the Linkerd examples repo. There's some nice demos in there that you can test out that functionality. Is gRPC support as solid as HTTP 1.1? I'd say it's close. We've just recently added gRPC support in the last few months. The last several releases, if you kind of look through our release notes, a lot of it's been in hardening and productionizing gRPC support. So I think if we're either there now or we're within weeks of it being very solid. If you test it and you see anything unexpected, of course, let us know. Drop into Linkerd Slack. That's probably the best way to reach out to us first. If you have a more complex issue, we'll probably move into discourse and work through that. But we are implementing Linkerd with some users that are working at very high scale to success. So we're gaining confidence in that day by day. Oh, thank you, Courtney. She mentioned we've got it's the same question. Yep, so as I said, gRPC support is about there, but definitely give us a heads up if you see anything else. Okay, well, I see some people, I see folks starting to drop. Oh, no, we've got one more. Okay, no, thanks, Nicholas. These are good. How does Linkerd Viz discover Linkerd instances? That's a great question. So Linkerd Viz, as I said, it's composed of Prometheus and Grafana. And if you look in the Linkerd Viz repo, you'll see different Prometheus configs per platform. So there's a DCOS specific Prometheus config file in there. So when it launches on DCOS, it knows to go to Marathon and say, show me every Linkerd instance that's running on this DCOS cluster. It gets all the addresses that way. And you can always confirm that if you launch Linkerd Viz, we not only expose the Grafana dashboard, but we expose the Prometheus dashboard as well. It runs on a different port, and you can dig in and actually see the targets, which are the different Linkerd instances, kind of listed to confirm that they're all being collected from. And I'd say if you're running on a different platform than DCOS, hopefully Linkerd Viz supports it. And if it doesn't, let us know. Pull request welcome. Somebody added console support recently. So if you're running on console, Linkerd Viz would know how to find those instances as well. Okay, well, I think we're winding down here again. We really appreciate everyone for attending. If you have more questions or you want to learn more, please visit our sites, check out our blogs and all of that. I'm gonna share a few links on screen really quick just to kind of sum things up. Let's see.